Tiny bricks today, moon bases tomorrow. That's the bold question behind a new Chinese experiment that might change how humans one day build homes on the lunar surface. China has taken another concrete step toward its long-term plan to construct infrastructure on the moon by testing small, experimental lunar soil bricks in space for an entire year, and safely bringing them back to Earth for analysis. These test blocks spent 12 months exposed to the vacuum, temperature swings, and radiation of low Earth orbit aboard China's space station before returning with the Shenzhou 21 spacecraft, which also carried 3 astronauts, wrapping up a 6-month stay in orbit. Early checks show the bricks stayed in surprisingly good condition, hinting that similar materials might one day be used to build real structures on the moon instead of shipping heavy construction materials from Earth. What are these lunar soil bricks? The returned batch includes 34 small blocks, each weighing about 100 grams, made from materials designed to closely imitate lunar regolith, the dusty, rocky soil that covers the moon's surface. Engineers used advanced techniques such as hot pressing, electromagnetic induction, and microwave sintering to compress this regolith-like material into dense, sturdy bricks. Thanks to these methods, the bricks reportedly have a compressive strength around 3 times higher than a typical brick used on Earth, which is crucial if they are to withstand the harsh conditions of space, including large temperature swings, radiation, and potential micrometeoroid impacts. How did they hold up in space? After landing, researchers opened the storage container and were struck by how intact the bricks appeared: no visible cracks, dents, or holes from debris impacts, or other obvious damage. Interestingly, the bricks' color seems to have become slightly lighter after their year in orbit, and scientists are now investigating why this change occurred, for example, whether it is linked to radiation exposure, chemical changes in the material, or simple surface weathering in space. These early observations make the experiment look like a promising proof of concept, but the team still needs detailed lab tests to understand exactly what changed inside the material, not just on the surface. Why some bricks were pre-cut? Not all of the samples were solid blocks. Some were deliberately manufactured with symmetrical seams cut at a 45-degree angle before being sent into orbit. The idea is to compare how intact bricks and pre-cut bricks behave over time in space, and to see whether these seams weaken the material, or change how cracks might spread. By studying these variations, the team hopes to learn how joints, corners, and interfaces in future lunar structures might respond after years of exposure, which is vital when designing habitats, landing pads, or radiation shields that have to stay safe for astronauts. Beyond strength, heat and radiation. Mechanical strength is only part of the story. The experiment also looks at how the bricks handle heat and radiation after long-term exposure. Real lunar buildings will have to cope with extreme temperature cycles, from blistering daytime heat to freezing nights, and constant radiation, so understanding how the material expands, contracts, and degrades is essential. To make sense of the results, the team kept a control group of identical bricks on Earth, so they can compare the spaceflown samples with those that stayed in normal terrestrial conditions and isolate the specific effects of the space environment. Predicting decades of lunar use. This is not a one-off test. The researchers plan to fly and return multiple batches of samples, and the set that just came back is only part of a longer series. Once the third batch is recovered, they aim to compare all the results horizontally, meaning side by side across different exposure times and configurations, to look for consistent patterns in how the bricks change. With enough data, they hope to build a model that can forecast what these materials might look like after 5, 10, or even 20 years of service, and then apply that knowledge to predict how similar bricks would age in the actual lunar environment. China's bigger moon-building vision. All of this feeds into China's broader lunar roadmap, which includes sending astronauts to the moon around 2030 and assembling an initial version of an international lunar research station by about 2035. Long-term presence on the moon is enormously expensive if every kilogram of building material must be launched from Earth, so China plans to lean heavily on local, in situ resources such as lunar soil, solar energy, and minerals already present on the surface. Using lunar regolith to produce bricks and other construction elements on-site could drastically cut costs and launch mass, opening the door to more ambitious bases, laboratories, and infrastructure. The controversial question: how far will this go? Here's where it gets interesting and potentially controversial. If experiments like this succeed, future lunar bases might be built mostly from local material, giving whichever country masters the technology first a significant strategic advantage in space infrastructure and science. Some will see this as a brilliant example of innovation and resourcefulness, while others may worry about a new kind of competition over who gets to industrialize the moon first, and under what rules. And this is the part most people miss. If we learn to turn lunar soil into reliable building materials, it could reshape not just exploration, but also space law, international cooperation, and even debates about owning or managing parts of the moon. So what do you think? Should turning moon dust into bricks be a global, cooperative project, or is it fair for any nation that develops the technology first to lead the way and set the standards? Would you feel excited or uneasy seeing the first moon base built largely from local lunar soil? Share where you stand and why.